thank you for the introduction, and thank you for giving me a chance to talk here. I'm Yuchi Otsuka from RIKEN. So let me start with self-introduction. I'm not a computer scientist. I got my PhD in physics, and I have been working on condensed matter physics for a long time. And since 2022, I have been in charge of OSS on Fugaku. So I don't have a computer science background, but even though I have been able to maintain software on Fugaku, at least I hope so. So this experience shows that Spack is already very useful, at least for me. And RIKEN is one of the largest institutes in Japan, with more than 3,000 researchers among many fields. And RCCS, RIKEN Center for Computational Science, is our center for HPC, which is located in Kobe. And so far we have developed and operated the two flagship supercomputers. That is a K-computer and Fugaku. K-computer was a Spack-based supercomputer and retired in 2019. And at that time, we used a traditional way of module load and manual installs for softwares. On the other hand, in Fugaku is ARM-based supercomputer. We employ Spack to provide OSS. So thanks to Spack, we can provide firmware OSS. And I'd like to note 2 points about Fugaku. One is Fugaku is heterogeneous system. That is, login node is standard Intel machines. On the other hand, computer nodes use ARM CPU, and users usually compile their code on login nodes with Fujitsu compiler, Fujitsu cross compiler. And Fugaku has a layered storage system, which is composed of two file systems. One is a FEFS, Fujitsu exabyte file system, which is based on raster, and it is a second layer and used as usual data storage. And we also have LLIO, lightweighted layered I/O accelerator for each node. And this is a first layer storage for high-speed access. And this is used as a caching or temporary space. So we need file transfer from FEFS to computer nodes. And this is not very trivial and sometimes cause many problems. And why the name Fugaku? Fugaku is an old name of Mount Fuji, which is the highest mountain with wide foothills. So we choose this name to imply both high performance and wide usability. And from a viewpoint of software, Fugaku is a leading supercomputer adapting Spack, because only a few other systems use Spack. And most of the Japanese HPC users have used or want to use Fugaku. So we can say there are many potential users of Spack in Japan. They move to building OSS on Fugaku. We have very simple policies to provide OSS on Fugaku. We provide widely used software as pre-installed. And we also encourage users to install their own favorite OSS by themselves. And we use Spack for both cases. And support policy is best effort. And we don't support whole individual OSS in principle. And packages are provided as is, but some key packages are optimized. And however, case by case, we also accept requests from users. And to realize these policies, we prepare a public instance in which important common OSS are supplied. And we prepare just one instance for each version, which manages both login nodes and computer nodes. And users are encouraged to install additional OSS in private instances on top of the public instances. And all instances are installed on these second layer file systems. And we haven't applied, we only apply very few modifications to Spack itself, because the default configuration is very good. And we have only one local repository which contains updated built-in recipes and Fugaku specific packages and tune optimized variants. And in the latest public instance, which is based on version 0.21, it contains 120 built-in packages and 156 local packages. This is a list of public instances we have provided so far. This is versions and the time we have the services started and corresponding official date of release. So we typically follow every other major release, and there have been about 3 months time lag between official release and installations. So we cannot claim that we have updated very frequently. So why this time lag happens? So one reason is Fugaku specific environment, because many packages are not yet compatible with ARM CPUs and Fujitsu compilers or libraries. And of course, this is not a problem with Spack itself. And we expect this situation should improve as ARM-based systems increase. And we also think CI/CD may help to mitigate this problem. And Yoshifumi Nakamura in our team is evaluating Jacama CI or Fugaku. And to overcome this issue, we expect more comprehensive tests on ARM systems and also better auto detection of system packages. And the next issue is slow compilation. So sometimes big package takes much time. For example, we had to wait about 2 days to compile Rust and 33 hours for LLVM, and so on. So this is mainly because we have to build packages on compute nodes. So each single node of compute node, the performance is not very high, and the Fujitsu compiler is slow. In addition, an overhead of file transfer is significant for computer nodes. So this is a pain point, and we expect cross compilation is realized in the near release. And third point is about parallel installation. Parallel build can be possible, but due to complex dependencies, a single mistake can cause many rollbacks. So we find step by step often turns out faster and more transparent. That means easy to understand the problem when something goes wrong. And we also find even trivial package can fail in parallel installations, often during concretization. This is possibly due to latency when transfer file transfer for each parallel for each installations. And we don't know why it happens, but we expect more robust caching or locking during cognitions may help. And last thing is about unstable concretization results. Spack specs can result in very different results. This is especially this is the case for especially for the large packages such as PyKeras. This shows a part of concrete spec of PyKeras. And for this issue, omitting or doing Spack garbage collection or concurrent installations may affect these issues. And by setting this, we may avoid this issue, but it is not very efficient. So I think this is very interesting and difficult problem. But I just want to know, I want just run best practices. And this is packages that were very difficult to build. So Julia cannot be built with Fujitsu compilers, or to build this new version of GCC requires these conditions, but we don't know why we need this. And LLVM, it takes much time, and so on. So we don't know if these problems are ascribed to Spack Fugaku or should be reported to the upstreams. But we have made it trouble so far. So let's move to maintenance of software on Fugaku. So since July 2022, we log each Spack load invocation with its recipe and related versions by this Python script, which is written by our team leaders. And these are raw results of statistics. And because many softwares are installed by Spack in the public or private instances, so we can gather a large data set. So these data are very useful for making future plans to provide OSS. For example, this is a list of supported softwares on Fugaku. So to update this list, these data were usefully taken into account. And as for user support, we accept questions or requests from users at Zendesk. And surprisingly, we have received a few questions concerning about Spack itself. So we think users can understand how to use Spack, even though we only provide a very simple manual. And also we notice not so many requests to install additional packages. So we think many users set up their private instance to install their softwares. So generally speaking, so support effort is surprisingly reduced by employing Spack. But not all users are happy. So some users complain about, for example, Spack load is slow. So yes, actually this can happen. Loading package can be very slow, especially for large packages consist of many shared libraries. And this overhead can be reduced by setting this workaround, but we don't understand this workaround works very well. And some users complain that they cannot load some packages. This is often our fault, but occasionally package that should have failed to install remains indexed. So we have to do Spack index or uninstall. And if this happens to a key packages like LLVM, and this was really case, and in that case we have to rebuild so many dependent packages, and this can be problem. And in summary, first of all, Spack is highly effective for building the OSS environment on Fugaku, but still catching up with new release can still take months. So these are features we expect in the near future of Spack: cross compilations and better auto detection of system packages, and more build parallelism, and also more comprehensive tests on ARM systems. Finally, I'd like to comment about the next supercomputer. We are planning to build the next flagship supercomputer, which is called Fugaku Next, and which is expected to build literally in next to the Fugaku. And this feature will be further appreciated in this next flagship supercomputers. Thank you.
All right, thank you so much. Questions?
Have you tried adding -pipe to your GCC build flags for C and C++ to avoid file systems for intermediate files and compilation to see if that speeds things up any?
I haven't tried.
Okay.
It's my understanding there's sort of virtual Fugaku machines available in AWS. Have you tried building on those instead of on your compute nodes?
Virtual Fugaku? This?
Yes, but have you tried actually using that to do your builds rather than your Fugaku compute nodes, which you said there were issues with?
Of course.
Build there and run on Fugaku?
Virtual Fugaku itself is not available on Fugaku.
All right, anyone else? Okay, one more.
You log the Spack load calls of the system install. Do you also log the number of users who are using private instances?
No, it should be.
That could be very interesting to back up your comments about how easy it is for them to use.
But we can calculate the number of private instances from this data.
Oh, so it logs the private loads as well?
Yes, because we record each hash, so we can calculate the number of Spack load for public instance or private instance.
Okay, I think Nick Sly is next, if he wants to start. Or is he in here? Okay, and then we can answer one more question while he's doing that.
Just a quick question. You mentioned that Spack loads is slow because you have T8 storage. Can you comment on how big your Spack tree is? I was just curious.
We don't understand this problem very well, but we have to cache some files at these first layers.
Yeah.
So in some cases, we avoid this problem by setting this. This is, we don't cache the file.
I see.
But not always this avoids.
So it just goes to the next level, which is the bigger one.
Yes.
Gotcha.
All right, thank you so much.
Thank you.